Hello all, good morning. This is Dr. S. Subbalakshmi, an assistant professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Matrices and Calculus, and now we are on to the topic volume of solids. In the previous video, we have seen the volume of sphere. Now we are going to find the volume of an ellipsoid, which is nothing but the three-dimensional figure of an ellipse. What will be the equation of an ellipsoid? It is x squared by a squared plus y squared by b squared plus z squared by c squared is equal to 1. As usually, we will take up the given equation, which is x squared by a squared plus y squared by b squared is plus z squared by c squared is equal to 1. And in the previous cases, we have seen the 8 into volume of the first octant, or we will be finding only the volume in the first octant, so that we will multiply it by 8 and get the whole volume. So volume of the ellipsoid is equal to 8 into volume of the first octant. What is your volume? Actually, this is triple integral over the region dz dy dx. To find the z limits, what we will do? We will just take up the given equation like this. It is x squared by a squared plus y squared by b squared plus z squared by c squared is equal to 1. Now what is z squared by c squared? It is 1 minus x squared minus a squared minus y squared by b squared. What is z? What is z now? Z now is c into root of 1 minus x squared by a squared minus y squared by b squared. Next, we'll move on to the y limits. What are the y limits? We have to put z is equal to 0. Therefore, x squared by a squared plus y squared by b squared plus 0 is equal to 1. Y squared by b squared is equal to 1 minus x squared by a squared. Therefore, y is equal to root of b into root of 1 minus x squared by a squared. Next, we have to find the limits of x. We have to put y is equal to 0 and z is equal to 0. What is that? X squared by a squared plus 0 is equal to 1. Therefore, x is equal to a. So we will implement this all these limits in the volume integral. What are these volume? Volume I is equal to integral 0 to a, integral 0 to b, b into root of 1 minus x squared by a squared, which is the y limit, and integral 0 to c, root of 1 minus x squared by a squared minus y squared by b squared, which is your z limit. So what is your I? I is equal to integral 0 to a, integral 0 to b into root of 1 minus x squared by a square. On integrating z, you will have dz, you have z alone. So within the limit 0 to c into root of 1 minus x squared by a square minus y squared by b square. So on top, substituting it as the upper limit minus lower limit, we have c into root of 1 minus x squared by a square minus y squared by b square dy dx. Now what we are going to do is, we are going to take the LCM here. What is our LCM? It is b square, and clubbing up these two terms. So we will have b square into 1 minus x squared by a square minus y square divided by b square. On taking it out of the square root, we will have c by b here. We will have c by b here. And 0 to a, integral 0 to b into root of 1 minus x squared by a squared, all others remains the same. On integrating it with respect to y, we will have to substitute this value to be t. What value to be t? This particular limits value to be t, so that it will be easier for us to integrate it. So if we substitute t is equal to b into root of 1 minus x squared by a squared, we will have root of t square minus y square here, which is dy dx. On using this particular formula here, what is that formula? X by 2 into root of a square minus x square plus a square by 2 into sine inverse of x by a. Here your x is y and a is t. Here your x is y and a is t. So therefore what will you get? C by b into integral 0 to a y by 2 into root of t square minus y square plus t square by 2 into sine inverse of y by t, where y is equal to 0 to t. Now where y is equal to 0 to t. So c by b into integral 0 to a, t by 2 into root of t square minus t square. So the first term will vanish. So the first term will vanish. The second term will become t squared by 2 into sine inverse of t by t. This is 1. What is sine inverse of 1? It is nothing but pi by 2 minus 0 minus sine inverse of 0 is 0 into dx. So what will you have here? C by b into integral 0 to a. The second term alone remains t squared by 2 into pi by 2. What is this? C by b into integral 0 to a, t squared by 2 into pi by 2. What is t square? It is nothing but b square into 1 minus x squared by a square dx. So what will be the constant terms outside the brackets here? C pi b squared by b 4 into 0 to a 1 minus x squared by a square dx. So this is how we are going to simplify it, and we are going to integrate it. On integrating it, what will you have? This is nothing but 1 minus x squared by a square. On integrating 1, you will have x. On integrating 1, you will have x, and on integrating x squared, you will have x cubed by 3. Within the limit x is equal to 0 to x is equal to a. So pi BC by 4 into, on now substituting the upper limit, you will have 3a minus a divided by 3. This is pi BC by 2 into 2a by 3. On on simplifying it, you will have I is equal to pi a BC divided by 6. Now what will be the volume of the ellipsoid? Volume of the ellipsoid is 8 into this particular thing. Therefore the volume will be 4 by 3 into 4 by 3 into pi ABC. So this will be the volume of the ellipsoid. So this is how we implement multiple integrals in finding the volume of solids. Thank you.